Thanks to our speakers, Manisha, Min, Hitesh, and Chao. We will now open up to 15 minutes Q&A, and we'll go through as many questions as possible. So please keep the questions coming. The first question I'm going to direct towards Manisha. So if you had to do your project, what would you do differently? And this is from Vipul.
Redo. Wow. We just, it took a village to do this. It took a pretty large art. But I think one thing could be that we figured out that a different metric is needed. Although we had the intuition quite early, we started working on it much later in the project. And I feel like that's one of the things that we would preload if we were to do this again.
Thank you. So the next question, this is I'm going to direct to Min. How does Uber Generative AI platform detect hallucinations, which is a confident response by an AI that does not seem to be justified based on the training data? This is from Hamir.
Yeah, thanks for the question. So as we know, like hallucination detection is still a kind of open research topic. Right now we have used like multiple different solutions, like self-check chat GPT, the Nemo guardrail framework, and also a module in Llama Index as well. We kind of get like mixed results with them. It's not like bulletproof for sure. Again, it's still like an open research topic. The whole idea for our platform is we can plug and play different modules as they being available in the open source community, or and also we are developing ourselves as well.
Thank you. Keep the questions coming. So the next question I'm going to direct to Hitesh is, how does the system manage multi-tenancy for a large number of models?
Thanks for the question. There are multiple aspects of the multi-tenancy. I'll try to cover a few of them and how our platform tries to handle them. One of the aspects is the isolation. Given that large number of models are deployed and managed by this single platform, we need to make sure the isolation is pretty good. For example, at the host level, we make sure that the platform leverages containers, which means that each model is deployed as a separate container, separate service. So there is isolation at the host level. Similarly, at the global level also, we make sure that there is enough demand control across these different tenants, different models, so that one model and one tenant is not actually taking all the resources, which needs to be shared among multiple tenants. So that's more on the isolation. There's also aspect about the config management, because it's pretty common for these large number of tenants to actually share some base configuration while overriding and modifying a few set of smaller configurations only. And then the system actually provides this unified data model that we talked about. It allows us to encapsulate and encode that configuration with the hierarchy and inheritance, and also allows us to make the changes in a more safer and paced way. But yeah, there are definitely, this is an active topic where a lot of things needs to be done to make sure the system is multi-tenant and provides guarantees and safety for that.
Now going to a question for Manisha. Of the optimization techniques you mentioned, if you were to pick one and focus on one first, which one would you pick, and why?
Let's see. I think the one mentioned in the Google's Moat article as well, which is Allura, that just has huge amount of possibilities. And I feel like it really comes down to what you're comfortable with. So if you're comfortable with CUDA and the lower levels of the system, then I would start with CUDA graphs. If you're more comfortable on the higher level, then start with LoRa. So you can go through the talk either from the end to the beginning or beginning to end, and then figure out where your comfort zone is. And that's the one I would pick.
So I'm kind of trying to select, there are a lot of great questions here. Maybe like this one is interesting. Maybe between Chao and Hitesh, one of you could take this. What is a common unit to compare different hardware for AI inference in the IP Next ecosystem that you discussed? This is from Sudhir Konru.
Do you want to take the question? Hitesh, or I can answer it?
So let me try. Go ahead, Chao.
Thanks for the question. I think if you talk about the units, I think it's actually different use cases. I think for some cases, we just have the heterogeneity across the same model parts. In this case, you just have one kind of a common functionality you can run on either of one of the hardwares, and we can actually try to choose the one to run. And in some other cases, things become more complicated. So when you're actually running with a different hardwares, you may actually choose to partition the model differently. For example, you in the setup one, you just have one server running everything within the same server. In another setup, you actually because of the limitation of the certain hardwares, you have to split the models into multiple parts. So in this case, the heterogeneity unit become the model itself instead of in a host level. So I think depends on the use cases, we actually need to handle the heterogeneity in different levels.
Cool. So in general, there are a couple of kind of interesting questions. What are like specific challenges related to, I'm just going to keep this open to the panel. What are the open kind of security challenges that you expect from AI/ML specific platform perspective?
That's like at least for Azure ML, there are three different flavors of security challenges that come in. The first one that we all know is the user safety, and responsible AI and various different things are doing a lot to break the grounds there. But then there is also the IP security. Since it's OpenAI and Microsoft joint collaboration, the IP security also plays a pretty big role. And then the third angle, because it's a cloud, is also the enterprise security, that making sure that the publishers and subscribers' IP is protected properly as well, be it the training data for fine-tuning or the inference data, making sure that that's handled properly. And collectively, there's a huge amount of effort that goes into security aspects, pretty much as optimization, which is neat.
I see. Maybe that has covered most of it. So why don't we kind of go to the next question, which is how does the system account for real-time events and traffic changes? This is directed towards Hitesh.
Yeah, thanks for the question. In general, the capacity supply is based on the traffic demand. So if there's any change in the demand for the system, whether it's expected or unexpected, right? The expected demand could be a region is being tested or shut down, right? Or unexpected demand changes could be, for example, a disaster has happened. System tries to actually incorporate for those changes in real time as those changes are happening. In terms of system design, there's a clear separation of responsibilities between the systems, which tries to expect these behavior. For example, the planner that we covered today in the talk tries to make sure that the expected changes in the distribution of the users is accounted and how we do the capacity placement across multiple regions. While there is a real-time system like with the auto-scaling kind of system, which will work more with the disaster and unexpected changes as well, and how they account for that too. This is more for the capacity side, but definitely there is a lot of other aspects like traffic changes across cross-region routing. And I think we will have a session tomorrow where we talk about service router and how we do cross-region routing. So probably that will be the best place to cover those changing questions.
Yep, tune in. That's going to be a good place to kind of cover those discussions. Yeah. The next question, this is going to be directed to Chao. Can you please give an example of splitting model into modules? What does that mean?
So a lot of times, I think when basically you have a model, for example, the model is too large, they have a very large embedding table, and it's cannot host in one machine. In that case, it's because of RAM limitation. In this cases, you have to cut the model into multiple places. And sometimes when you have a model, you have a different parts. They have a pretty different batching requirement because the batching is pretty important for the efficiency for the AI accelerator. You might be decide to actually split these two parts in different places so that they can have a different kind of batching behavior to make both parts efficient. So there are actually a lot of other examples because of different needs. Folks decide to actually split the model into multiple parts to make it efficient or make the serving possible.
So somewhere kind of in the neighborhood of this question, there's another question that's also directed to you, which is how does the system handle snapshot transitions?
I think, as I mentioned, we're in a heterogeneous environment, so there are actually a lot of different requirements for snapshot transition. To me, they are kind of the trade-off mainly between the efficiency, model freshness, and the model consistency. For our platform, we actually support different snapshot transition protocols based on different needs. For example, when we want to handle the snapshot transition with the model consistency requirement across different parts, in high level, we try to split the capability into two things. We try to support the capacity shift, and we try to support traffic shift separately. Then we try to build a protocol on top of this two things and try to let the traffic shifting following the capacity shifting to make sure that while the transition is smooth, we still guarantee the consistency across the period.
Thank you. So I think we can try and sneak in a couple more questions before the break. The next one may be directed to Min. Is the pipeline in Uber declarated like Argo workflow or Python native like Ray or ML flow? This is from Li Zhang.
Thanks for the question. We actually support kind of both. We have a workflow system called MLN, which is Python-like. Basically, you can write a workflow using Python language, and we're going to trace the workflow DAG and execute that. But that's mostly for advanced users. For majority of users, we have a declarative one, as we explained in the presentation called machine learning application framework. So that's more like a YAML or Python based, or YAML or a protocol based declarative workflow.
Okay. So we may still have a little bit of time, but let's see. So for Manisha, you clearly spent a lot of effort optimizing LLMs. If you don't have enough resources to optimize all the many things that you did, what would you recommend focusing on for both training and inference that gives the most bang for the buck? This is from Nisarg. Thank you.
So I think it Nisarg means human resources and not machine resources, hopefully. If there is a limited, a smaller org, I would go with the higher level optimizations in-house and go for as much open source as possible for the lower level optimizations. So leverage XLA, leverage Onyx, leverage various different pieces, and then focus on the routing and scheduling layer and metrics.
Okay. So I'm going to sneak in one last question and we kind of get to the break. So this is a question directed to either Uber or Meta panelist. How are these platforms baking in cloud FinOps principles? Let's assume that FinOps is related to cost compliance, attribution, mandated by the company's financial posture. How are these kind of getting accounted for in these platforms?
Yeah, I can try to
go ahead. Thank you.
Yeah, so that's actually a great question. Uber is actually a pretty big company, like probably not as big as Meta, but we actually have very complicated organizational structure as well. So like Macanya as a ML platform support many different business units as well as organizations. So we do support some kind of basic kind of chargeback or shieldback, basically to the job layer where we would launch a job, we track like how long the job executed, and then report that to a centralized a system, which not only for ML but for data, for microservice, everything else, which shows how much resource each organization use. And of course, we don't really do like AWS kind of like you have to pay the money, but we do track like the resource usage and the financial implications of the models. And also we kind of push some kind of ROI for the ML models, because without like appropriate like ROI structure, you have like lots of models which really don't have enough business impact, but use lots of resource in the system.
So yeah, Hitesh, just seems like you want to give your perspective.
Yeah, maybe I can add to what Ben said. Yeah, at this scale, definitely the cost is one of the key thing we all care about. And definitely, and it's not specific to just inference or training, right? It's broader than that as well. In general, at Facebook, definitely we attribute costs at the server and the host level. But definitely, when the models are much smaller and more distributed, we also try to attribute at the resource usage level itself, not just at the host or the server level. So it's a combination of that. And all the tools and accounting and capacity placement we talked about today actually considers that and takes that into consideration into how should we actually be optimally allocating the capacity so that it's globally optimal for the whole business and the whole company.
Thank you. With that, I want to thank all the panelists and great presentations and everyone else who's made this as successful as possible. Quick note before the break, we'll be starting 10 minutes. In 10 minutes, when we come back, we'll be covering a second theme of the day, which is hyperscale infrastructure. See you soon. Thank you.